All right, let's look at section 2.2, the derivative function. The function f prime, defined by the formula this, is called the derivative of f with respect to x. Now notice, the derivative of f prime is the same thing we've been doing, except instead of x subscript to 0, we just have x's in there, okay? And then your book says this. It says the domain of f prime consists of all x in the domain of f for which the limit exists. All right. Let's look now at doing our first example. If you look at the handout, well, it's not really a handout technically, so, since I didn't hand it out to y'all, but if you look at the notes that are posted on Moodle, what do we have? Find the derivative with respect to x of f of x, this is part A by the way, of f of x is equal to 9 over x squared. Find the derivative of f with respect to x of this function. All right, so we have this new notation, f prime of x. Well, we just said with the definition we had up, the derivative is the limit as h approaches 0 of f at x plus h minus f of x all over h. Let's calculate this. This is the limit as h approaches 0 of 9 over x plus h squared minus 9 over x squared all over h. All right, to evaluate this limit, what I'm going to do is I'm going to get a common denominator here and here so I can subtract these two fractions. So we're going to have the limit as h approaches 0 of 9 over x plus h squared. Leave a little space and then put minus 9 over x squared all over h. Now the easiest way to come up with a common denominator here and here is multiply this fraction by the other one's denominator, top and bottom. So I'm going to multiply this denominator by this one's denominator, x squared. Well, what I multiply by the bottom of that fraction, I got to multiply by the top, right? This fraction here, I'm going to multiply the numerator and denominator by the other one's denominator, x plus h squared. Let's see what that gives me. That gives me the limit as h approaches 0 of 9x squared up top here. And then, could I write this as x squared times x plus h squared? Sure could. Minus 9 times x plus h squared over x squared times x plus h squared all over h. Let me make sure everything is still on the screen here. Yeah, sure is. All right, so let's see. If I have a common denominator here and here, I can write the denominator one time and put the numerator as 9x squared minus this stuff. So let me carry over the limit. Limit as h approaches 0 of 9x squared minus 9 times x plus h squared, and write that denominator down one time. X squared times x plus h squared all over h. All right, so what I'm going to do now is I'm going to expand this part out. Okay, I'm going to square the x plus h. So I have the limit as h approaches 0. Let me do this to kind of separate it. Limit as h approaches 0 of 9x squared comes down, minus 9 comes down, but this part squared gives me x squared plus 2hx plus h squared all over x squared times x plus h quantity squared. Now let's do a little bit of cleaning up here, okay? This is all over h, but isn't h technically h over 1? And how do you divide fractions? You multiply by the reciprocal. So I'm going to put times 1 over h right here if I multiply by the reciprocal. Makes it a little neater to write. All right, so next we're going to distribute -9 through here. So we still have the limit as h approaches 0 of 9x squared minus 9x squared minus 18hx minus 9h squared all over x squared times x plus h quantity squared times 1 over h. As you can see right here, this term and that term zero out. Now up top, these two terms, you can factor h out of them. So I'm going to write this as the limit as h approaches 0 of, let me factor h out the top. So if I factored h out the top, I'm left with negative 18x minus 9h to the first over x squared times x plus h quantity squared times 1 over h. Now, why did I factor that h out the top? Because I saw if I do that, I can divide it out with this h over here. Let's see what we have left. We have the limit as h approaches 0 of negative 18x minus 9h over x squared times x plus h squared. Now, can I evaluate this limit? Can I plug in 0 for each h and be okay? I sure can, so I get negative 18x minus 9 times 0 over x squared times x plus 0 squared. Let me see, I don't think I can go down anymore. I think I got to go to the side now. Yeah. So that gives me negative 18x over, isn't this x squared times x squared, or x to the fourth? So that'll give me negative 18 over x cubed, right? Negative 18 over x cubed. Now, what did this problem ask for? It asked for the derivative. So basically, f prime of x was equal to what? Negative 18 over x cubed. Another way we could write our final answers, we could say f prime of x is equal to negative 18 over x cubed, like that. Now, what did we just find? Yeah, we found a derivative like it said to do, but what else did we find? What is this derivative right here? It is an equation for the slopes of the tangent lines, of all the tangent lines to this curve right here. So in other words, you got that curve right there. What's it look like? Something like this. So what does this formula give you? It gives you the slope of the tangent line here, 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 and so forth. So it gives you the slopes of all the tangent lines on that curve. Let's look at part B. Part B. Let me erase some stuff here so I have room to write. All right, what does part B want? Part B says, give the equation of the tangent line at x is equal to negative 1. Give the equation, I'm going to abbreviate, tan line at x is equal to negative 1. Okay, I can't remember if I said that negative 18 over x cubed gives you a formula for all the tangent lines. If I did, I meant it gives a formula for the slope of all the tangent lines there. All right, so give the equation of the tangent line at that. Okay, so what was my original function? F of x was equal to what? We had like 9 over x squared, right? And for part A, we found that f prime of x is equal to negative 18 over x cubed. So let's see. They want us to find the equation of the tangent line at x is equal to -1. The equation of the tangent line at x is equal to -1. So in other words, like let's say that I have -1 right here, okay? I want the equation of the tangent line to this curve at -1. I want the equation of that tangent line right there. How do I find the equation of a tangent line? Remember we said it's y minus f of x naught is equal to m tan times x minus x naught, right? And we filled in for this, this, and this. Well, let me see. What did they give me right here? They give me an x value, right? So I have an x value in an ordered pair like this. I need a y value. Yeah, they said x was -1, but really we could look at this as x naught is -1, a particular x value. Now let's find f of x or f of x naught. How do I find f of x naught? Well, it's just the output when the input is -1. So to find the output of the function, whenever the input is -1, sub in -1 right here. What do you get? 9 over what? -1 squared, or 9 over 1, or 9. Alright, so far I have y minus f of x naught we said was 9. It's equal to m tan, I don't know what that is yet, but I'm about to find it, times x minus x naught is -1. So minus -1 is +1. So all I really need to do is find m tan and then simplify here. So what is m tan? M tan. What was this? This was the derivative of f, right? Or the slope of all the tangent lines at f. What am I looking for here at -1? I'm looking for the slope of the tangent line at -1. So I'm really looking for this. F prime, which is the slope of the tangent line at that particular value of -1. Let me go over that again, okay? F prime of x is the slope of all the tangent lines, right? I want f prime at -1 to give me the slope of the tangent line at -1. So take f prime, evaluate it at -1. So here's f prime. You're going to sub in -1 there for x. -18 over -1 cubed. And what does that give you? Positive 18. So m tan is 18. So y minus 9 is equal to 18 times x plus 1. So y minus 9 is equal to 18x plus 18. So y is equal to 18x plus what? 27. There's my equation of my tangent line to this curve at the point x is equal to -1. All right, let's see what's next. If we look at our notes, we have an example that appears next. And it reads something like, given that, let me write some of this stuff down, okay, so I can point to it and so forth. It says, given that f of 1 is equal to -8 and f prime of 1 is equal to 5, find an equation for the tangent line. Find equation of tangent line. And x is equal to 1. Now I'm abbreviating these instructions. It's technically a tangent line of y is equal to f of x and so forth. Alright, so what am I looking for? I'm looking for the equation of tangent line. First thing you should think of with equation of tangent line is y minus f at x naught is equal to m tan times x minus x naught, or x sub 0. But wait a minute, I don't have an equation here. My function's not written as an equation. That really doesn't matter here. Because look at what they do give you. What does this mean right here? What does f of 1 equal to negative 8 mean? Well, one interpretation of this is if I input 1 into my function, I get an output of negative 8. And don't you have order pairs that look like this? Input, comma, output. So if I input 1 is my input, I get an output of negative 8, right? So basically what that's saying is I have x subscript of 0, f at x subscript of 0. Now let's interpret this part right here. F prime of 1 is equal to 5. What is f prime? That's a derivative, right? But isn't it also the slope of the tangent line at 1? So they're saying m tangent at 1 is 5. Or in my case, I could say m tan is equal to 5. So I want the equation of the tangent line at x is equal to 1. Well, that just gave me all the information I needed. Y minus f at x naught is what? Negative 8. It's equal to m tan, we just said was what? 5 times x minus what? 1. Now just clean this up. Y plus 8 is equal to 5x minus 5. So y is equal to 5x minus 13 is my equation of my tangent line. Next, your book talks about computing instantaneous velocity. Okay, computing instantaneous velocity. And you're going to see that next in your notes. Talks about computing instantaneous velocity. And your book reads something like, if f of t is the position function of a particle in rectilinear motion, if f of t is position function, remember this is a particle in rectilinear motion now, then your velocity function v of t is the derivative of your position function f prime of t, which is given by what? The limit as h approaches 0 of f at t plus h minus f of t all over h is your velocity function. And as you're going to see in the notes, it talks about it's the instantaneous velocity function, or simply called the velocity function. So what is this saying? If you're given a position function and you need to know the velocity function, what do? Take the derivative of your position function. Let's work the example that appears next. All right, our example says what? Find the velocity function of a particle in rectilinear motion with position function. Position function f of t is equal to 3x, 3t squared minus 2. Find a velocity function of a particle in rectilinear motion with that position function. Statement we just had said, okay, if you want to find a velocity function, what do? You take the derivative of your position function. And how do you take the derivative of it? You say the limit as h approaches 0 of f at t plus h minus f at t all over h. Well, that's equal to the limit as h approaches 0 of 3t times t plus h squared minus 2 minus 3t squared minus 2. Y'all done this 100 times. You should be good at it now. So what does this give me? The limit as h approaches 0 of 3t squared plus 6ht plus 3h squared minus 2 minus 3t squared plus 2 all over h, if we expand that out. All right, here, these two terms zero out. These two terms zero out, right? So I'm left with 6ht plus 3h squared in the numerator. And I can divide each one of these terms by this h in my denominator. So that leaves me with the limit as h approaches 0 of 6t plus 3h to the first. Now evaluate this at 0, the h value anyway. 6t plus 3 times 0 is equal to 6t. So what is my velocity function? My velocity function v of t is equal to 6t.